In gameplay, every time a sound is played, a small amount of processing power is required from the game system's CPU. While audio puts a relatively small load on the processor, consider that the processor must be shared with other aspects of the game, such as 3D graphics rendering, and this can put a tremendous stress on the system. For this reason, we need to be aware of how to maximize the audio engine's use of the processor and not waste processing cycles unnecessarily. Every sound played in a game requires something called a voice through which it is played, and every active voice uses processor cycles. In games like the Cube demo, for which we have its project shown here, voice counts can quickly rise when you have your character firing a weapon at 30 bad guys, who are all firing their weapons back, plus the sound of all their footsteps and all the other background ambient sounds. It can really start to add up quickly. The distant footstep takes just as much processing power to play as the gun being fired 2 meters away, so to render sounds that are unlikely to be noticed is really a waste of processing cycles. To minimize this waste, we can define a minimum volume that the sound would need in order for it to actually be rendered through a voice. In the main menu, choose Project, Project Settings, and in the General tab, we see a variety of platforms listed here, and this list will vary depending on what you've configured for your project. Values for things like volume threshold can be set independently for various platforms, which is important because a Wii has considerably less processing power than a PlayStation 4. The default setting for volume threshold is -80, which is a value expressed in decibels. This means that there's 80 dB of dynamic range in the game. If we wanted to relax the load on the game system's processor, we could reduce the dynamic range by changing the volume threshold to a higher value. But be aware that if you do this, there's a risk that some sounds that you want to hear, such as maybe subtle ambience, may end up getting cut off. Just for demonstration, we'll set this value on the Windows platform to -50 dB. There's also another property that defines the total number of voices that are allowed to play through the system at any one time. This prevents overloading the system altogether. Lowering this property's value ensures that the audio engine will require less processing on the CPU, but again, it means that some sounds that the player really needs to hear, like a line of dialogue, may get cut off. Don't worry, we'll learn how to prioritize voices later. Just as a demonstration, we'll lower the max voice instances for the Windows platform to just 40, and then click OK. Some sounds, by their very nature, can be real voice hogs. In Cube, some of the weapons found in the weapons actor mixer are rapid-fire weapons, like this CG1 Sound SFX object. It's a chain gun. Now here I only hear one shot at a time, but in game, this weapon fires very quickly and the sounds tend to overlap each other, causing the voice count to rise very quickly. To help with this, it's possible to manage how many voices any object might use at any one point in the game. Now we'll go back to the Weapons Actor Mixer, and then choose the Advanced Settings tab in the Property Editor. Now here we'll see a playback limit area, which allows us to set the total number of voices that can be used by any particular object. We'll go ahead and select the Limit Sound Instances checkbox. And remember that this setting is therefore applied automatically to all child objects contained within, in this case, all of the other weapon sounds in the game. We can set this so that the limit number applies to each game object, meaning that each character would have 50 voices available for their particular weapon, or it can be set globally, meaning that no more than 50 weapon sounds of any one type would be heard at the same time. We'll set this to globally. This can be quite useful, as it's unlikely that the player would be able to distinguish much more than a handful of sounds of the same type played at the same time. For this same reason, we'll go ahead and lower the instance value to 25. There are some sounds that we want to make sure never get killed regardless of what's happening in the game. To accommodate this, Wwise has a voice prioritization system where we can rank types of sounds according to their importance. This way, when the game system must kill voices, it doesn't silence sounds like critical dialogue or music that we wouldn't want to drop out unexpectedly. In this case, we'll protect the cube main theme, which is kind of a melodic ambience that needs to be persistent throughout the game. So we'll go down and find the cube main theme. And then in the sound property editor, we can see the playback priority area. Now, right now, the value for its priority is set to 50, which is the default value for all objects in the game. We'll go ahead and change now its priority to 80, which means it's nearly impossible for the music to ever be inadvertently turned off during gameplay. Now, just below, we can see an offset priority checkbox setting. Now, this specifies a value by which the priority of an object is offset when it reaches the max distance value specified in the attenuation editor. In other words, if a sound is really far away, it gets less priority. But this doesn't really apply to the music. This is helpful for prioritizing objects such as footsteps that need priority when they're close to the listener, but are less important when they're far away. The footsteps are found in the main character actor mixer. Let's go up, main character actor mixer, expand it, and find the footsteps. Now, the footsteps are also shared by non-player characters. Now, remember that an object always takes its property settings from its parent. So if we want to make a change in playback priority, we first need to override the parent. Now, we can go ahead and set the priority for the footsteps to a value of 60 to ensure the player can always hear his own footsteps. But then we'll click the offset priority value and change its value to -20. So any non-player characters that are far away, those footsteps now get less priority. Also in the Advanced Settings tab is the Virtual Voice area. Virtual voices represent sounds that would normally play, but their volume or priority is too low, so they are moved to a silent virtual voice. Although the sound is inaudible, certain parameters of the sound are monitored by the sound engine, and if related circumstances change, the object can automatically move back into a physical voice and be heard again. This can be useful for longer sounds where it's okay if the sound drops in or out of the mix. For example, let's look at the rocket launcher used in the Cube game. If we move down and we find its actor mixer and expand it, we see that it contains this thrust sound. The length of the thrust sound varies depending on how long it takes to reach its target. But if needed, we can set it to go to a virtual voice if the game's overall voice count gets too high. But if the voice count lowers, its sound will automatically return as if it had never dropped out. We'll need to first go to the virtual voice area and then override its parent. Now, in the virtual voice behavior property, we can change the value to say, send to virtual voice. Below, in the on return to physical voice property, we can change it to say, play from elapsed time. And this will set it so that when the sound returns back to the physical voice, it'll be heard as if it had never dropped out. So you can see there are many different options for ensuring that our audio always stays within our system's available CPU resources.